Okay, everyone, we'll get started with the afternoon session of the webinar. Today we're going to be talking about subroutines and how to do them in the FC6A series PLCs. Just like always, if you've been on one of these webinars before, if you want to ask a question in your control panel, just click on the questions drop down, type in your question and hit send. And we will do a Q&A session at the end of the webinar. Also want to make sure everyone knew that these webinars are being recorded. They will be posted on our YouTube channel and also will eventually migrate to our website as well. After these are finished, we will put together a question and answer document from the questions that we received this morning and the questions from this session. We'll put all those together in a document for you, as well as provide a PDF copy of the presentation. We'll put those up on our cloud file server, and once Marcom processes the video, usually takes about a day or so after the webinar is over, they will send out an email to everyone who attended with a link where you can go and grab all that information. All right, so let's get started. What is a subroutine? Well, in essence, a subroutine is just a basic subsection of your program that performs a specific task. It could be anything that doesn't really need to go in your main program, something that doesn't need to happen all the time on every scan of the PLC. For example, if you were around for the scaling and data conversion webinar that we did a couple of weeks ago, you'll remember that we read the temperature off of a thermocouple from one of the analog cartridges in the FC6A. Maybe that doesn't need to happen every scan of the PLC. Maybe once every 15, 20, 30 seconds, something like that, you want to read the temperature. That's an example of something that you could put into a subroutine. So why would you want to use a subroutine? When I thought about it, there's really three main reasons that whenever I'm writing a program that I like to use it. One, it just cleans it up. For me, I mean, I'm not that smart of a guy. If I'm looking at a PLC program that's got 900 rungs, I get overwhelmed instantly. So it can help to clean up your program. It can make it easier to troubleshoot if you have things in sections or compartments. It can also make it a lot easier for you to reuse portions of your code for other applications where you don't need to go and reinvent the wheel. You don't have to write that same code over and over again. If you do it in a subroutine, you can do it once. Once it works, leave it there. Then you can pull it into other applications. So let's take a look at a couple of instructions that you can use when you do subroutines. The first one that we'll take a look at is the label jump, or L jump. And what I'm showing here is at the top of the ladder, those first four rungs where we've got an input going to an L jump instruction and then followed by an end statement. That is basically the main program. Now, granted, you could have additional logic in there if you wanted to. That's not a problem. But for our example, that's the main program. So all it involves are three jumps to execute three different subroutines and an end statement. Now, this shows an example of how we used to do subroutines in the past, and they can still be done this way, where all of your subroutines come after the end of your main program. So everything after that red line is a subroutine, and there are three of them there. We identify a subroutine with a label. You'll see that label instruction right there beneath the red line. The number indicates simply the subroutine number, and we can have subroutines numbered from 0 through 255. So you can have up to 256 total subroutines in your program. So the way the L jump instruction works, just for example, let's take that very first rung of code. When input 0 turns on, an L jump is going to be performed, and we're looking for a source value of 0, basically something we're looking for label 0. So if input 0 is on, the program will jump to where it says label 0. It will then begin executing the code from that point. In this example, we've only got one line of code. We've got a normally open contact of M8121, which, if you guys remember, that is our 1 second clock special internal relay. So what that's going to do is turn on and off output Q0. It'll be on for half a second, off for half a second, on for half a second, off for half a second, as long as that subroutine is called. So once we execute that code, we hit the end statement, the ljump instruction, control goes back to the rung from which the jump took place. So in other words, it goes back to the very top of the program to I0, okay? Just as an example, let's say we have input 0, input 1, and input 2 on all at the same time, okay? So what will happen is, again, we scan left to right, top to bottom, just like we read. So once we see that input 0 is on, we perform a jump to label 0, we execute the code, we hit the end statement, and we go right back up to the top where input 0 is. That's where the jump initiated. So in that example, if input 0, input 1, and input 2 are all three on, input 1 and input 2, those subroutines will never get executed, because the jump, when it sees I0, it jumps to label 0, executes that subroutine, and then it goes back to the same rung in which the jump took place. Okay, that's how label jump works. Now, we've also got label call, or lcall. Now, if you'll look at this program, you'll notice this is very, well, it's the same basic program that we just looked at. We're just using label calls instead of label jumps. Okay, so our main program looks identical. We just replaced lcall with, or ljump with lcall. So again, there at the top, input 0 calls subroutine 0, input 1 calls subroutine 1, input 2 calls subroutine 2. Now the difference is, let's take for example, if input 0 is on, we call subroutine 0. We jump down to label 0, we execute that code. Now, instead of having another end statement there, we have an L return, label return, okay? The way that works is it will return the control back to the main program at the rung after the label call, okay? So with an L call, if you have 3 L call instructions like we do in our main program, input 0, input 1, and input 2 can all be on at the same time, and each one of those subroutines will get executed. If input 0 is on, we execute subroutine 1, we bounce back, control gets sent back to the rung that starts with input 1. We would then jump down and execute subroutine 1, execute the code, we hit the label return, control gets bounced back to the rung after that, which would be the rung that starts with input 2. Input 2 calls subroutine 2, so we jump down to label 2, we execute that code, we hit the label return, and then we bounce back up to the rung that's after input 2, which is the end of the program. So it starts back up at the top. So that's the difference between using label jumps and label calls. Now, one of the things that we've done is within WinLadder, we've improved the graphical user interface, and we've came up with a new way to use the lcall instruction. The way this works is the subroutines are all held in separate tabs, if you will. And you can see on my screen there, we show the tabs at the top where we've got main program and module configuration. That's what we've seen for, well, all of the webinars that we've done so far. You'll see also up there, we've got 3 different subroutines that have been created. So instead of having the subroutines come at the very end of your main program, we've just changed the way it visually looks, and we put them in tabs to help keep it a little cleaner, to keep it more compartmentalized. All right. So let's look at some different ways to create subroutines with this new method. There's really 3 ways. One, if you go to your Home tab in the Subroutine/Macros section of the ribbon, you can click on that new dropdown and select subroutine, and it'll make a new subroutine for you. If you're looking at the workspace, where you've got the tabs all across your workspace, it starts with main program, module configuration. The next icon there is a new icon. It looks like a new document icon that you might see in Word. If you click on that, that will also create a subroutine. And finally, the last way, well, at least the last way that I know of, to create subroutines is if you go to your project window, and if you expand the programs section, you can right-click on subroutines, and select New. So there's 3 different ways to create a subroutine. Now, if you do it the first way or the last way, you will be prompted to pick your subroutine number. You can see that there on the left-hand side, that little drop down right beside the number 0. And again, you can choose a number anywhere between 0 and 255. And then also you can give your subroutine a name. By default, it's going to be called subroutine, but you can change that to pretty much whatever you want. If you use that middle method, where you just click on the new icon right above the workspace, the subroutine will be named subroutine and just automatically assigned the next available subroutine number. Now, no matter which of the 3 ways that you use to create the subroutine, and again, whatever way is easiest for you, whatever way you want to do it is fine, you can always modify the properties. You just go into the project window, again, go into the subroutine section, right-click on the subroutine that you're interested in, and click on property. From there, again, you can change the number, change the name. Another option that you've got within that box is you can also password protect your subroutine. Okay, so once you do that, if you do password protection on your subroutine, once you save your program and you close out of it, once you go back into your program, your main program, and open it up, if anyone tries to open up your subroutine, or if somebody tries to import that subroutine into a different program, which we'll go over importing subroutines here in a little bit, it's going to ask them for a password. And if they don't have the password, then they don't get access to the subroutine. And you can have different passwords, if you want, for each and every subroutine. Or if you want to keep it the same password for each and every subroutine, that's perfectly fine too. Passwords are case sensitive, and you need to have at least 6 characters, including at least 1 alpha character and 1 numeric character. So importing a subroutine, how do we do that? Well, if you go up to the home section of your ribbon, in the subroutine/macro section, you'll see we've got an import dropdown, and just click on that, click on subroutine, and it'll ask you to pick a program that you want to import a subroutine from. The other way to do it is just go into the project window, again, expand your program section, right-click on subroutines, and then select import. Again, either way will work. You'll be asked to specify a program name that contains the subroutine or subroutines that you want to import. Once you pick the program and you click open, then you'll be prompted with a list that shows all of the subroutines that are in that program. And you can pick and choose which ones you want to import. So in the example I'm showing up there, that particular program had 9 subroutines, and I'm choosing to import subroutine 0, the leak check, subroutine 7, the alarms, and subroutine 8, Modbus. Now, if you try to import a subroutine with a number that already exists in your current program, for example, subroutine 0, right? It's going to ask you to assign another subroutine number to the subroutine that you are importing. Okay, and we'll go over this so you guys can see how it works. But in essence, all it's saying is you can't have 2 subroutines with the same number in your program, right? I can't have 2 subroutine 0s or 3 subroutine 5s. The reason being is when I do an lcall instruction, it doesn't know which one to grab, right? So I need a unique identifier to be able to go to the correct subroutine. All right, the last thing I want to talk about in the PowerPoint portion of this is something called nesting. And what nesting is, it's when you call a subroutine from another subroutine. Now, subroutines can be nested for up to 4 total layers. All right, so let's take an example. We've got a main program, and let's assume that we've got 5 subroutines in this program, numbered 1 through 5. Okay, just as an example. They could be numbered whatever numbers, it doesn't matter. I'm just using 1 through 5 to keep it simple for me. So something like this could happen. The main program could call subroutine 1, that's our first layer. Subroutine 1 could call subroutine 2, that would be our second layer. Subroutine 2 could call subroutine 3, that would be our third layer. Subroutine 3 could call subroutine 4, that would be our fourth layer. Okay. Now, if we would have subroutine 4 try to call subroutine 5, that's when we would run into an issue because we're past that 4 total layers, okay? And those subroutines could have been any number. In other words, subroutine 1 doesn't necessarily have to call subroutine 2. It could have been subroutine 38. Then subroutine 38 could have called subroutine 9. Subroutine 9 could have called subroutine 7, for example. But you can only do 4 layers maximum before you return control back to the main program, okay? If you try to do that, if you try to go past 4 layers, then you're going to get special internal relay M8004 will turn on in the PLC, so you'll have an indicator. You'll also get the red light of death on the PLC. That red LED, the red air LED will flash, or not flash, but it'll turn on solid as well to indicate, hey, there's a problem. So just something to keep in mind. Perfectly legal to call one subroutine from another. Just remember that you can only go 4 layers deep before you return control back to the main program. All right, so let's do an example. I'll open up WinLadder, and we will take a look here at an example. And let me make sure, yeah, okay. Just want to make sure you guys are seeing my WinLadder screen as well. All right, so what I'm going to do here is something similar to what I showed in the PowerPoint. All right, I'll make a main program with simply 3 rungs. Each rung will call a different subroutine, and then I'll make 3 different subroutines, and we'll kind of see how they all work. So here in my main program, what I'm going to do is I'll have a normally open contact, and I'll assign that to input 0, I0. So when I0 turns on, I want to call, and I'll call subroutine 0. Now, your subroutine instructions are under your advanced instructions down to program branching. And here you have label, label jump, label call, label return. Those 4 instructions that we talked about a little bit during the PowerPoint. Again, for this example, I want a label call. I'll left click to drop it in, double click to edit it. Now I've got one source, again, S1, and here this is going to be subroutine number 0. So when input 0 comes on, I want to call subroutine 0. So I could put a 0 here, okay? You can also use a data register in here if you want, okay? If you want to make this a variable condition, right? In other words, if I did something like this and put D0 in here, data register D0, then whatever number I pump into data register D0 will be the subroutine that gets called whenever input 0 turns on. Again, that would have to be between 0 and 255. Okay. So just know that that is an option if you so choose to use it. For this example, I'll just go ahead and hard code the subroutine numbers to make it easier. So again, input 0 will call subroutine 0. Let me delete this little ladder line here. Hit enter to make a new rung, and I'll do something similar. I'll make 2 more rungs. What I'll have is input 1 will call subroutine 1. And I will also have on rung 3, I'll have a normally open contact of input 2. And I will have that call subroutine number 2. So that's my main program. 3 rungs, I'm good. Now let's go make some subroutines, okay? So I'll do one this way. I'll come up here and click on this new icon right beside the module configuration tab. That'll create subroutine 0. Okay, again, the next available subroutine is subroutine 0, so that's what it just created there. Again, if I want to be able to modify the properties of that, like we showed in the PowerPoint, I can go into my project window, expand the program section, expand the subroutine section. I can right click on the subroutine I'm interested in and hit property. So again, from right there, I can change the subroutine number if I want. I can change the subroutine name if I want. Okay. And we'll go over the password protection in just a little bit. All right. So I've got subroutine 0. That's the tab that's open. I'm in here so I can write the code for that. And what I'm going to do is I'll have a normally open contact of special internal relay M8125, and that's our in operation output, or I call it the always on bit. The reason being is that bit is always on if the PLC is in run mode. If your program is being executed, this bit will be on. And what I'll do is have that control an output. And to do that, I'm going to use a dual timer instruction. And if you guys were on the webinar that Mr. Kirk did on data logging and trending, this instruction will look familiar to you. Basically, all this is it's a timer where you can specify source 1 is your on time. How long do you want this output that you're controlling to be on? And in this case, I'm going just to hard code this at 3 seconds. Again, we could use a data register there to make it variable. Source 2 is your off time. Again, I'll hard code that. We could have made that a data register to make it variable. Destination 1 is the output or the internal relay, either one, that you want to control by this timer. In this example, I'll use physical output Q2. And destination 2 is a workspace that the instruction needs, and I'll just use data register 10 to hold that information. We won't be using anything here, just all we'll be interested in is the on time, the off time, and the output that's being controlled. That's it for that subroutine, okay? With the new way that the lcall instructions work, we do not need to use a label return in here, okay? Just like in our main program, you'll notice I did not put an end statement. We just assume, we'll put it in there for you once you download, but we just assume that if you're done here in the main program, if you don't write any more code, we'll just automatically insert the end statement at the end of the program when you download it, okay? So in other words, if I were to download this and then upload it back out of the PLC, I would have an end statement here, but we don't make you put that in. If you want to, you certainly can. That's not a problem. Likewise here in the subroutine, again, we don't require you to put in a label return, an L return instruction. We just assume, okay, if this is all the code you've got in your subroutine, if you don't call another subroutine from within this one, then we're going to send control back to the main program at the rung following where we call the subroutine from, okay? All right, so let me go ahead. I'm going to make 2 more subroutines. I'll make subroutine 1 and subroutine 2. Let's go ahead. I'll make subroutine 1 by going through the project window since we haven't done that yet. So I go to the project window into subroutines here, right click on it, click on new. Again, that'll pop up a dialog box and ask you what subroutine number do you want to create. Again, I'll make subroutine number 1. Again, I can change the name here if I want. And I'll call this dual timer. Since this is going to be a dual timer, just to give it a different name so you guys can see it up here in the tabs. Click OK. And now it opens up subroutine 1, dual timer. Okay. This is going to do something very similar to what subroutine 0 did. I will use a normally open contact of special internal relay M8125. And I'll use another dual timer instruction. And in this case, what I'll do is I will have it turn on for 2 seconds, off for 2 seconds. I'll have this control output Q3, and I'll specify maybe data register 20 for the work area for the instruction. Okay. So again, this is going to be whenever this subroutine gets called, output Q3 will turn on for 2 seconds, off for 2 seconds. Okay. And as long as we're calling this subroutine, it will keep happening just like that. All right, let's go make subroutine number 2. And this time I'll do this through the Home tab up here. So the Home tab in your subroutine/macro section of the ribbon, you click on New and click Subroutine. Again, that'll open up that dialog box and prompt you for a subroutine number and a subroutine name. I click OK, that will make subroutine 0. And again, this is going to be very similar. I'll have a normally open contact of M8125. I'll have that go to a dual timer instruction. And here what I'll have it do is I'll have it control an output where it's on for 1 second and off for 1 second. And I'll use output Q4 for this. And maybe D30 for the workspace. All right. So I've got 3 subroutines and a main. Again, subroutine 0 is going to turn output Q2 on for 3 seconds, off for 3 seconds when it's called. Subroutine 1, when it's called, will turn output Q3 on for 2 seconds, off for 2 seconds. And subroutine number 2 here will control output Q4, and it will turn it on for 1 second and off for 1 second when this subroutine is called. All right, let me go ahead and download this. And what I'm using here is just an FC6A D16 PLC, one of the FC6A plus PLCs, one of the 16IO versions. Let me download this. And then we will take a look at how this works. So let me go into monitor mode. And I'm going to open up a batch window. I want to look at my outputs. I'll start it with output number 2. And I want to look at my outputs as binary bits, just either on or off, so I can see each individual output as it turns on and off. Shrink that up a little bit, and I'll stick that right there. So now what I'm going to do is I'm going to turn on the switch that controls, or that's wired to, input 0. And what we should see is output Q2 here will turn on and off every 3 seconds. Okay. So input 0 is on. It's calling subroutine 0. And again, as long as that input is on, that subroutine will be called. So Q2 will turn on for 3 seconds, off for 3 seconds, on for 3 seconds, off for 3 seconds. Okay. Let me try input 1. Okay. Let me turn the switch on for that. That will call subroutine 1, which is controlling output Q3. And if you remember from the subroutine, output Q3 will be on for 2 seconds, off for 2 seconds, on for 2 seconds, off for 2 seconds, as long as the subroutine is being called. Okay. And finally, let me turn on input 2, and that controls output Q4. It'll be on for a second, off for a second. Okay. Now, if I turn on all 3 of the inputs, right, all 3 of those subroutines are getting called. Remember, how it happens is we start at the top. If input 0 is on, it goes out here to call subroutine 0. Call subroutine 0, executes the code. Since subroutine 0 isn't calling any other subroutine, control gets sent back to my main program at the run following the lcall instruction. If input 1 is on, call subroutine 1, goes to subroutine 1, executes that code. Again, we're not sending it anywhere else, so it goes back to the main program and starts executing with rung 3. Okay. Now, one thing that is important to keep in mind, okay, for example, I just let go of the 2 switches that control input 0 and input 1. Okay. Input 2 is this is our training kit, so input 2 is our selector switch. It's still on, so subroutine 2 is still getting called. You can see output Q4 here. It's still turning on and off once each second. Okay, but what happened? Output Q2 is still on. Output Q3 is also still on. Okay, something to keep in mind when you're doing subroutines. It's perfectly legal to turn on and off your outputs within your subroutine. Nothing wrong with that. What you want to make sure of, though, is that you are calling your subroutine on a regular basis so your outputs can be updated, okay? Just like in this example, I'm not calling right now in subroutine 0 or subroutine 1, so these two outputs, they're in the last state that they were in when the subroutines were last called, okay? So I could do one of two things. I could make sure that this subroutine is called on a regular basis, or I could also put some additional code in my main program that says, hey, if output Q2 happens to be on longer than whatever time I want it to be on for, I can force it to turn back off. Okay. So again, just something to keep in mind when you're using subroutines. Okay. All right. Now let me show you how to import. Okay. Let's take a look at importing some subroutines. Then we'll look at how to password protect the subroutines. So again, if I want to import, I can go to my Home tab in the Subroutine Macros section here and click on Import Subroutine. I can then choose whatever program that I want that has the subroutines that I want to bring in. For example, this program. Okay. So what it's going to do is, it's not going to fully open that program, but it's going to examine it and show me a list of all the subroutines that are within that program. Okay. I can choose whichever ones I want to import. Let me choose 0, 1, and 8. So I'm importing my leak check subroutine, my analog conditioning subroutine, and my Modbus subroutine. Okay. Now, we've already got subroutine 0 and subroutine 1. So what this should do is pop up a dialog box and say, hey, you've already got these two subroutine numbers in your existing program. And it does. It tells me subroutine number 0 is already used. Pick another number. And since I've used subroutine numbers 0, 1, and 2, it starts with 3. That's the first one available. I can pick and choose whichever one I want. It doesn't matter. As long as it's not used, I can pick any number. Okay. So in this case, I would be importing subroutine number 0 from that other program as subroutine number 27 into this one. Likewise, subroutine number 1 from that other program, maybe that's imported as subroutine number 12, for example, into this program. Okay. Now the last subroutine, the Modbus, we didn't have subroutine number 8, so that came along just as it was, right? Now I've got all those different subroutines here in my program. All right. Now let's say I want to password protect some of these, right? Maybe I build leak check equipment, and this subroutine leak check contains some really proprietary information about how my machine works versus everybody else's. And I don't want people just being able to get into that, right? So if I want to password protect that subroutine, I can right click on it, go to property, click on the enable protection checkbox, and then I can type in what password I want to use to protect the program or to protect the subroutine. Okay. Now let me go ahead and save this. I'm going to close the program and open it back up to show you how that password will function when you try to open that subroutine. So let me save this. I'll save this as that in my documents folder. Okay, let me go ahead and close this. Now if I go open that program back up, and we'll give it a second here to open, then I'll try to open that subroutine number 27 that I just password protected, so you guys can see how it functions. Okay. So here in my project window, again, it was subroutine 27 that I password protected. Normally, if you want to open up any subroutines in your program, you can either just right click on them and click edit. See how that'll open subroutine 0. Or if I want that subroutine 1, I can just double click on it. It'll open it up here in my workspace. But if I try to do the same thing with subroutine number 27, it's going to tell me, hey, that's password protected. So I can't open it up. I can't do anything else with that particular subroutine. It will execute in my program fine, but I can't see the underlying logic unless I put in the password. Okay. Once I do that, then fine, it'll open it up, and I didn't have any code in there. I just called it leak check, but I had no code in there from that other program. Okay. Now, likewise, if you want to close any of these tabs that are open up here at the top, all you've got to do is at the top right-hand corner of your workspace, so all the way over here at the right, you've got this little X. You can just click on that X, and that'll close whatever the currently open tab is that you've got. Okay. And again, it doesn't affect the program's operation if you have anything open here or not, as far as if I don't have to have subroutine 0 open in a tab for it to execute or anything like that. It's just being able to show it, monitor it, and modify it within my workspace. All right, so that's password protection. Now, one thing to keep in mind, okay, and this is very, very important, is that if you have password protected a subroutine, and this is going to sound silly, but I'm being serious, make sure you remember the password. The reason I say that is we don't have a way to either recover your password or strip out the password from the program so it's no longer password protected. We don't have that option, okay? So if you password protect a subroutine and you forget the password, there's really nothing else that we can do to be able to get in there and give you that logic back, okay? Now, if I want to take the password protection away from that subroutine, right? I go in here and I delete these passwords, that's fine. But it's going to, let me open it up. Got to have it open before I can delete it. Okay. If I want to go in here and delete, I don't know. No, this is acting different than the last one. Let me disable it. Yeah. So if I try to disable this password protection, right, it's going to ask me for the original password. So in other words, if you have something that's password protected and it gets opened, and then you decide, yeah, hey, I'm just going to delete the password protection in there, you still have to go back and enter the original password to remove it. Okay? All right. Well, that is subroutines, how to use them in the new style, how label jump and label call work, how to import subroutines, and how to password protect subroutines. Okay. One other thing too that does come up is, okay, you can import subroutines, but can you export them? No, you can't. For example, if I go in here and try to click on a subroutine, I've got no option here to export it back out. I can import from another program, but I cannot import from this, or excuse me, export from this program to another program. Okay, I can import, but no export. All right, so let me go. I will take a look at the questions now. Let me go over here and open the questions pane here in the control panel. Let's see if there are any questions. Like there's some. Let's see. The questions that we've got is, can you delete a subroutine if it's password protected? You can, but you've got to have the password that it's protected with in order to delete it. Let's see, the next question is, if subroutine 1 calls subroutine 2, do you put an end label in subroutine 1? Good question. No, you wouldn't have to. So for example, let me open up subroutine 1 and subroutine 2 here. And let me close that leak check because that might make this confusing. So I've got subroutine, and I need subroutine 0 open. So for example, if within subroutine 1, I want to call subroutine 2, all I would have to do is put in here, I could put in a label call instruction to call subroutine 2. Okay. And that's it. I still don't need an end statement in here. Once I hit this L call, it'll jump out here and execute subroutine number 2. Okay, so the next question, it says, nesting has a limit of 4 layers. Can you use macros after the 4th one before having to return to the main program, or will you still get an error? you can go, so you can call up to 4 subroutines. A user macro is something that you can put within a subroutine, but it's not considered a separate subroutine. So once you get to that 4th level past the main program, you've got to send control back to the main. Next question here. It says, with a number of options available, what drives the decision to use a script, a macro, or a subroutine? With multiple ways to potentially accomplish the same goal, are there reasons to choose one over another, personal preferences, or what? Between a macro and a subroutine, they're very, very similar, no doubt. The main difference between macros and subroutines, macros can be put into a main program. They can be put into a subroutine. Okay. Macros and subroutines can both use variable data. In other words, just like in this second subroutine I've got open here with my dual timer. Again, I could have used data registers. I couldn't put arguments like we use A arguments in macros. I couldn't put an argument in for source 1 or source 2 or destination 1 or destination 2 for that matter. But I can use variable data. In other words, source 1 or source 2 could have been a data register that I could pump different values in and out of. Absolutely. But that's really about the only difference between macros and subroutines. I like using macros, particularly when we do stuff with motion. It makes it simple for me to, like if I want to do a jog, I just simply put I've got all the code written in the macro, and then in my main program, I just say I'm using that particular macro, and I've got arguments that I can just fill in for the data registers. So if I need to do, 15 jog instructions, all I do is I've still got the macro written once. I can put in my main program the 15 jog instructions. For each argument, I can use different data registers. And then for each jog instruction, I've got different values, and it makes it simple. As far as like scripting, why would you do that versus ladder? It's really personal preference. There are some things that you can do a lot quicker in scripts than you can do in ladder. Just like when Steve went over scripting the other day, he did a math calculation, and it's one line in script. It can be multiple lines in ladder. So it's really personal preference. You can do, there's really nothing that I know of that you can do in script that you can't do in the ladder. So it really just boils down to personal preference and what you're more comfortable with doing. Let's see, the next question. Would the label jump command only be used within a specific main program or subroutine, or would it be used to jump between subroutines in a similar way to the label call? Yeah, you could use it in a similar way to the label call, just depending upon where you want to return control back. So in other words, in here, if I would want to, like my main program, right? I've got these 3 rungs. Let's say I call subroutine 0, right? Let me bring it up. So in subroutine 0, if I wanted to return control back to that first rung, I could put an ljump instruction here to go back to 0. Okay. Or not a label jump, but a label return, and it'll send it back here. Okay. So I could put a label return, excuse me, I misspoke. I could put a label return there, and that'll force it back here. Okay. And let's see. All right. Well, that's all the questions I've got, guys. I want to thank you again for attending the webinar. I want to let you know also, we just added some more webinars. If you guys aren't sick of listening to us yet, maybe you will be. We've got some more coming up. I did want to show you guys those. Our Marcom department is going to be sending out, I believe, another broadcast email to everybody in the contact list, just to let them know. But we've added everything from April 20th and down is something that's new. It's not already been on the schedule. So you guys are already registered for these. You just have to join at the appropriate time if you want to. That one main link where you guys registered already, just like for this webinar, we'll be doing all of these at 11 Eastern and 2 Eastern, so 2 sessions, just like we've been doing. Tomorrow, obviously we're doing subroutines today. Tomorrow we'll be doing some HMI stuff for the next few days. We'll be doing trending and data logging tomorrow, alarms, user accounts, animation, recipes. Then the week of the 20th, we go back to the PLC. We're going to redo the Modbus communications one. That was the first one that we tried to do that we had so many issues with the GoToMeeting platform with the audio. So we're redoing that in its entirety. So that'll be on the 20th. Then we're going to jump into some more basic stuff. Okay. When we started doing these, we didn't know how long these were going. We were going to be basically sheltering in place at our homes, and so we wanted to get out some of the more advanced stuff that we don't get a chance to cover during some of the trainings that we do, the in-person trainings. But now that we've got some more time, we are going back and doing some of the basic stuff. So we'll be doing, again, with the PLCs, not that Modbus is basic, but that's something we wanted to do and we just didn't get to. But on the 21st, we'll be starting from scratch. Make a new program, pick the PLC, configure some cards, how the digital cards, analog cards get mapped, things like that. Okay, just, again, ground up stuff. And it's great. It's great as a refresher. It's great if you are just getting into IDEC PLCs and you joined in some of these, higher end webinars and you're like, holy cow, what are you guys doing? This is a way for us to get back to some of the basics. The 22nd, we're going to be covering some basic circuitry, start-stop circuits, latching and unlatching circuits, series circuits, parallel circuits, things like that. On the 23rd, we'll be going over timers. The 24th, we're going to be doing counters. We'll show you guys examples of all 3 different types of counters that we have. On the 27th, we'll show you how to move data all throughout the PLC. We've done some of that in some of the programs that we've done in the webinars, but again, we'll start at the ground up and do some data moves. The 28th, we get back into a little bit more advanced stuff with the device data list, which is actually how you can save values into the PLC in a file. We'll get into some advanced math. And I don't mean this as a silly statement, but we'll be talking about multiplication to start that advanced math session. Not that multiplication is all that hard. But what we run into a lot is if I'm multiplying, let's say I've got a value in D0, I multiply it in D1, I store the result in D2. Well, what actually happens when you do binary math, when you multiply a 16-bit data register by a 16-bit data register, your result is actually 2 data registers. So the result actually gets put into 2 consecutive data registers. That's really easy to miss. I do it all the time when I'm doing programming. So we're going to start with that. And then we'll show probably 1 of 2 different examples. And I'm not going to be doing that webinar. Elias is doing that one. And I'm not sure which one he may show, but it'll be 1 of 2 different examples. One would be like if you want to calculate the volume of a cylindrical tank, how to do that. You've got to use some trigonometric functions to do that. We'll show an example of that. We won't build all the code from scratch. We'll show you how to do it, but and we'll make the example available, obviously, but we won't spend the time, I don't think, building that entire program up. The other possible example might be for a solar tracker, where if you know your longitude and latitude and the date, based on that information, you can calculate the optimal position of the sun to capture energy with a solar array. And we won't go through all of the physics and all that kind of stuff in doing that, but show you some of the advanced math. And we do have customers that do that, so we don't want to, take a chance of giving away any trade secrets or anything. But that's, that's a formula that's out there. It's publicly available. It's nothing that's custom to anyone. Then after that, then we jump back into some HMI stuff. So again, the HMI stuff on the 29th, we start with the basic stuff. Creating a program. How do you pick, the driver that you want to use for communications? In other words, what am I talking to? Am I talking to an IDEC PLC, a Modbus device, an Allen Bradley PLC? What am I talking to with that touchscreen? And some basic configuration, and we'll do some basic buttons. A bit button, a pilot light, stuff like that. We'll continue on the 30th with some more basic objects that everybody uses. And then we'll end up on the 1st of May with some advanced stuff. And, between now and then, we'll have to take a look and see if, if we're still doing sheltering in place and all that, then we'll probably add some more webinars at that point. So again, you guys are on this webinar, you're already registered, just go to that same link and log in, and you can join any of those you like. We're also we've been doing some product training webinars, and I don't know if any of you guys have joined those. If not, there's a separate link to register for those, and I'll leave this screen up a little bit so you can see it. But we've been going over just some of our different products and how to design them into applications and what you want to be aware of, things to consider. We did one on relays that was Phil, one of IDEX automation sales engineers, just did a fantastic job on. We're actually doing a repeat of that on the 14th. Today, we're going to be getting into force-guided relays and safety relays and our safety controller. Tomorrow, we'll be doing like a deep dive on the safety scanner, our safety laser scanner, like how to program it, how to set up different zones, things like that. So again, if you guys want to join those, you're certainly welcome to do so as well. That does have a different link, like I said, than these webinars that we've been doing, the programming webinars. And there's the link for that. It's just https:// register.gotowebinar.com/register/ then just the session number. And that session number is good for all of those, which is 3494-1713-9317-1229-452. All right. And again, after, these are being recorded, obviously. So all of the presentation, we'll save that as a PDF. We'll do a consolidated question and answer document. We'll post that and the recording as well. That'll be pushed to our YouTube channel and eventually make it to our website. Once the video gets processed, it'll be a day or two, and then our Marcom folks will be sending out an email to everyone who is on this webinar and the morning webinar with a link to where you can go and download all that material. All right. So again, just wanted to thank you all for being on this, and hope you all stay healthy and safe. Thanks again, and enjoy the rest of your day.